Hi, my name is Evan Chambers, and today I will be discussing the design and launch aspects of the SAVE Venus atmospheric probe. Firstly, I'd like to talk about the probe's design. This will include the basic design of the probe as well as some more specific aspects. The basic design is meant for a floating atmospheric probe. This would be designed to float high in Venus's upper atmosphere using a large balloon to support it filled with Earth air, which acts as a lifting gas. The main focus of the probe's design is in survivability. It needs to be able to survive in Venus's atmosphere with harsh conditions, which include both highly varying pressure and wind, as well as high concentrations of sulfuric acid. The probe body itself is divided into two main sections, an autonomic section and an instrumentation section. I'll get into what these are shortly. This is a diagram showing the basic design of the probe. As you can see, there's a large balloon above the probe body which supports it, as well as the autonomic section in the top and the instrumentation section in the bottom. There's also a few other instruments which can be seen from the exterior here. The autonomic section is the top section of the probe, and it's intended for making sure that the probe is able to carry out its basic functions. Some parts that are included in this section is solar panels, a probe computer, a battery, the main balloon, as well as an emergency parachute, and a high gain antenna. The solar panels and battery provide power to the probe. The probe computer controls all of its functions. The balloon is meant to provide aerial support for the probe, and the parachute can be used in emergencies. And the high gain antenna is intended for communication with Earth. The instrumentation section is on the bottom, and this includes all of the scientific instruments that the probe needs to conduct experiments on the atmosphere of Venus. This includes chemical spectrometers, which are used to identify elements and compounds that exist in its atmosphere, electromagnetic sensors, which are used to detect lightning and other electromagnetic phenomena, a DNA sequencer, which is used to test if there's any life existing in Venus's atmosphere, a barometer used to record the pressure that the probe experiences, and a radar altimeter, which is used to determine the distance to the surface so that the probe can orient itself, as well as creating an accurate map of Venus's surface. The second aspect of the probe I'd like to focus on in this presentation is payload delivery. This includes the probe taking off from Earth and leaving from Earth to Venus, as well as it entering Venus's atmosphere. So, the rocket launch vehicle is the first aspect of this. This is the part that brings the probe from the ground into Earth's orbit. It consists of two stages, and it will be using an Atlas V rocket. The first stage of the rocket is a larger liquid stage fitted with 3 solid rocket boosters. These provide the initial lift to take off. Once it reaches a certain altitude, it will discard the first stage, and a Centaur rocket second stage will take it from high altitude into orbit. After the initial launch rocket is depleted, the spacecraft will engage. This is intended for interplanetary travel. It consists of a main engine, some retro thrusters, and a solar panel and battery, as well as navigational sensors. Finally, I'd like to talk about the orbital profile. This includes 3 phases: a geocentric phase, which is liftoff in Earth orbit, a heliocentric phase, which is the interplanetary transit of the probe, and finally a Venus-centric phase, which consists of Venus orbit as well as landing the probe within Venus's atmosphere. This is the conclusion of this presentation. If you have any other questions, I would refer you to the rest of the main paper regarding the SAVE probe. Thank you.